Hi guys, I heard that there was a little bit of trouble on the practice day on these last two questions, and so I thought I would make a video going over them. I have not, I know what the answers are, but I haven't actually worked them out all the way, and so we're going to see if we can do it together here on this video. So first thing is I'm going to change the system into a matrix form. I'm going to start with that first one. And we need to double check and make sure that I did that right. So I've got 6, -1, -1, 4, -12, 2, 2, -8. Notice I'm just looking at the coefficients. 5, 1, -1, 3. And you can put the little dotted line here if you want to, but you don't have to here. Okay. So let's start doing some row operations to try and get the row, either the row echelon form or at the very least get zeros down in this corner right here. I feel like it's looking kind of gross. I also feel like it would be kind of nice if this number was a 1 so that I could get rid of, like, do it easier multiplication instead of having to do a fraction thing. So I am going to do row 1 minus row 3 for a moment. So if I do row 1 minus row 3, that means row 1 is the one that I'm replacing. I'm going to have 1 and then -2, 0, and 1. And I feel like that just kind of makes that matrix a little bit nicer to work with overall, having a 1 up there. Got to make sure you're extra careful with the negatives. Okay, so now I'm going to work on getting a 0 down this bottom left corner. I'm going to move over here. And this is going to be row 3 minus 5, row 1. So row 1 stays the same. Row 2 stays the same. And then this is going to become 0. So I'm kind of imagining multiplying this row by 5. All right, so if I multiply that by 5, that's going to become 10. And it's going to be 1 minus, let's see, minus -10, the -5 and the -2. So that's going to become 11. And then 5 times 0 is still 0. So this is actually going to stay -1. And then this is going to become 5. So I'm going to get -2. Okay. Next up, I usually try to get a 0 in this position. Because if I can get a 0 in this position, then I can use this row to help get rid of this number. So for matrix number 4, I'm going to do row 2 plus 12, row 1. And this is why I changed row 1 to have a 1 in that first place, just so it would be easy to multiply stuff. So row 1 is going to stay the same. I'm going to imagine multiplying row 1 by 12 and then adding it to row 2. So this is going to become 0. This is going to be -24. So 2 plus -24 is going to be -22. 12 times 0 is still 0, plus 2 will be 2. And then 1 times 12 will be 12, plus -8 will be 4. I'm noticing something here. Okay, so I can either, this is helpful now that I have zeros here and here. What do you notice that these rows are almost kind of opposites of each other? That probably means that, like, this one of them is going to cancel out. And if we can cancel out the last row, I think that makes the most sense. So before, just so I don't, I guess I could just multiply this. Imagine multiplying row 2 by 1/2. Or I could actually multiply it by 1/2 just to make it look nicer. Either way, the fewest steps would be to do row 3 plus 1/2 of row 1. Nope, row 2. Or I could just multiply row 2 by 1/2, or I could multiply row 3 by 2. All of those will give me eventually the same result. I'm going to do it all in one step here. So we can only do one like thing at a time. So I can't like also multiply this by 1/2 and add it. I need to do it separately. So I imagine adding this row to 1/2 of this row. And so that's going to be 11 plus -11. And that's going to be -1 plus 1. And then that's going to be -2 plus 2. Okay, so I actually have, this is interesting. The reason why I'm pausing is it seems like the way this is worked out, that almost like y is the free variable because I have a 0 here, and I also have a 0 here. But I think that I could actually maybe put these together so that y is not the free variable. Let's just work with what we have, because then I do have a z in this problem. So I think what I'm going to do is let's just start with saying z is the free variable because it's my last. I've got my whole last row equal to zeros there. I'm kind of noticing that maybe you can do it multiple ways. It depends on how you got your zeros and if you ended up with a 0 here. So there's probably multiple answers you can get for which one's the free variable. But if I start with the second equation, it's -22y plus 2z equals 4. Remember, whatever the free variable is the one that you want things to be in terms of. In other words, like I need to get y alone so that the equation is in terms of z. So I subtract 2z from both sides. I have 22y. Not sure why it keeps highlighting stuff. 22y equals 4 minus 2z. Divide by 22. Okay, so I have y equals, if you wanted to actually divide these, you could, like 4 divided by 22 would be the same thing as 2 over 11. And 2 divided by 22 would be 1 over 11. Or you can leave it like a fraction like that. Okay, so now I have y in terms of z, so that's good. I was just double checking my answer with what Mr. Yosef got. We're so far so good, but we did it in different ways. So that just kind of proves the fact that there's lots of different ways to do these problems. All right, so now if I take a look at this first equation, that's going to be x minus 2y equals 1. And remember, since z is my free variable, I'm trying to get things in terms of z. So I could actually replace this y right here with this, because remember, like this is substitution, like this is what y equals. So x minus 2 times 2/11 minus 1/11 z. You could distribute that -2. So x is going to be, oh, nope, sorry. It's going to be x minus 4 over 11 plus 2 over 11 z. And then we want to get the x by itself. This equals 1. So if I add 4/11 to both sides, sorry, my 2's and my z's look really similar, so that's confusing. I'll try to make my 2 a little curvier. Okay, I'm going to add this 4/11 to both sides. So I'm basically adding 4/11 to 11 over 11, so I'm going to get 15 over 11. and then I'm going to subtract that 2 over 11z from both sides. And I think I actually got a slightly different answer than Mr. Yosef did, and it looks like it has something to do with the signs here. So either I messed something up in my matrix up above with the signs, or maybe he messed something up, because we should have gotten the same thing, but they're really, really close. It's just like there was an opposite negative sign somewhere. We're gonna leave it. And here's the thing on the test too. We are definitely going to be taking a look at your work. These tests take forever to grade. And if you miss something like a negative sign or something, but like just one time and you do all the other work correctly, we're actually not going to take off for it. So sometimes we're going to end up with slightly different answers because of arithmetic errors. But if it only happens like once or twice, we're not really worried about it. If it happens like continually, then we will start taking off things, because it shouldn't keep happening over and over. I don't think we've talked about this a lot, but this is actually how you write the answer. You write it like a point, like x, comma, y, comma, z. So if it was numbers, like if this was an independent system and you just got a number for x, a number for y, and a number for z, you would just put them like this. Since I have an equation for x, an equation for y, and then I just have z free, I would write it like that. Okay, let's take a look at the system. And I'm going to see if I can copy it and paste it. So I have 1, 1, 1, 6, 2, negative 1, negative 1, 3, 1, 2, 2, 0. It took almost the whole matrix. For some reason, this row is like separate. There we go. Okay, I should mention that this matrix, by the way, because we got a row of zeros, that means that this was dependent, meaning that there's an infinite number of solutions. And in this case, all of our solutions relied on z. Let's take a look at this question. Okay, so again, my goal is always to get zeros in this bottom corner. So I think I might start off by just subtracting row 3 and row 1 from row 3. So that we can get a 0 in that bottom left-hand corner. 1, 1, 1, 6, 2, negative 1, negative 1, 3, 0, 1, 1, negative 6. So again, this bottom row came from that, subtracting, doing row 3 minus row 1. Next step, let's get a 0 right above it. And again, I feel like, and you guys, some of y'all might be able to kind of visualize more than one step at a time. I'm kind of just a one step at a time kind of gal. But I feel like getting a 0 in the bottom left corner, and then getting a 0 in the one above it, and then getting a 0 on the one to the right of it, getting the zeros like ultimately in this corner. But like this one, and then this one, and then this one usually is like the most efficient. Okay, so if I do row 2 minus 2 row 1, I didn't leave myself a lot of space, but row 2 minus 2 row 1, it's going to turn this into a 0. So this will be 0. This will be negative 3. This will also be negative 3. And then that'll be 3 minus 12. So I'll get negative 9. And this is still 0, 1, 1, negative 6 from matrix number 2. Let's focus on getting a 0 in this bottom row. I can either subtract 1/3, like the quickest way would be to do this row minus 1/3 of row 2. I also could do 3 times row 3 if that helps you out. If you'd rather not deal with fractions, that's always an option. So this would be 3, 3, negative 18. So 3 times row 3. Now let's go over here and add row 3 plus row 2, because again, I'm trying to focus on getting zeros, a 0 right here. Now, of course, you probably looked ahead and noticed that when I add these together, notice I just copied row 1 and row 2. When I add these together, it's not just that one that cancels. This becomes a 0, and this also becomes a 0. And then, oh, that was supposed to be a negative 9. This becomes negative 27. And as math would have it, 0 does not equal a negative 27. So that means that there's actually no solution. And the name of this type of matrix is inconsistent. You don't have to do anything else because there is no solution. So notice that I got almost a full row of zeros until the last thing. And so this is basically saying 0x plus 0y plus 0z equals negative 27. And obviously that is not mathematically possible.